looks good. And then we're going to hop over here and share. And we want to share this one. Okay. We're going to go like this. And we want to open up the chat. Just 25 topics, right? That's how my colleague articulated it. Just 25 topics a week, right? So just master 25 topics per week at a minimum. Okay, everybody can always do more. Together. Okay, I think I'm streaming. Let me make sure one more time. It looks like I'm streaming. Let me get rid of this. Okay, I think I am, even though I see those signals a little bit weak. I'm just gonna have to trust it for now. Okay, so let's take some time to go through the lessons that we need to go through for today as best we can. I'll just mimic what I did with my earlier students. Let's go view. Okay. Where's my timer? Okay. So it'll probably go a lot faster with you guys, but that's okay. So we're moving into the last section for chapter 1. Oh, let's do it like this because I remember how it likes to mess up for a moment. This one. So again, we're moving into the last section for chapter 1 for graphs and functions, and this is section 1.6, combining functions and composite functions. Let me see the time. Let's go like this. Let's go using. So then I need to do. Here. That looks good. I'm gonna hop back over here. All right. And now we gotta reboot that because that always says that. All right. And view. All right. Let's try this again. So again, moving into chapter 1 graphs, continue with chapter 1 graphs and function, and moving into section 1.6. Again, this is the last section for chapter 1, and we're going to anticipate exam 2 over the second half of chapter 1, starting next Wednesday, right? So just like we did exam 1. So some objectives for this section are we want to define basic operations on functions. So what do we mean by that? We want to form composite functions. We want to find the domain of a composite function. So we'll describe what do we mean, what's a composite function, right? So we will walk through that. We want to decompose a function and apply composition to practical problems. May I get a volunteer to read this slide for me, please? Let me see. If I go like this. Can I get a volunteer to read the slide for me, please?
I can read it.
Yep.
Let f and g be two functions. The sum f plus g equals, the sum f plus g, the difference f minus g, the product fg, and the quotient f over g are functions whose domains consist of two values of x that are common to the domains of f and g, except for f, g, where all values x, where g of x equals 0, must be excluded. These functions are defined as follows.
So all this is, we're doing like basic operations on functions. Just like we can add, subtract, multiply, and divide numbers, we actually have a notion. We can do a similar notion to add and subtract, multiply, and divide functions, right? Okay. So we see that here, right? So let's see. So okay, so let's kind of walk through this a little bit, right? So when we see this symbol here, right, a common error is that students try to distribute an x. We're not distributing x here. That's not what we're doing. What this just means the function f plus the function g. Again, this is read f plus g of x, right? And it just means, all it means is f of x plus g of x. Let me go let that person in. Okay, let's do like this. That looks better. Are you gonna freeze up on me? I knew you were gonna do that. But we got some late hairs, but they still got 5 minutes on the clock, so they're good. I just gotta get back in there. Come on. I'm probably gonna lock it at the 15-minute mark though. Come on. Come on. All right. And then we got. Okay. So now I'm gonna have to close that and go like this, get that to behave properly. We can let these two guys in. Let's put. We are here. And let's put this back, and we're gonna put it over here. View, single page, and let's pick up where we left off. Right here. Okay. So again, this notation. So again, a common error is that students see this x, and this even happened in my earlier class. When I first introduced it, I said, "Hey guys, this is not. We're not distributing. We're not distributing an x. That's not what we're doing here, right? We're not distributing x." I said it just like I said to you all. What this means is f of x plus g of x. Just add the two functions together. What this one means is f of x minus g of x, right? This is read f minus g of x. F times g of x. F divided by g of x, okay? And again, what this means is just f of x times g of x, right? So even though we went through the same presentation and then we did our breakout rooms, I still had students trying to distribute an x. I was like, no. But I was glad that we made that mistake together as a class. So that way, when we get on our own, we're less likely, we can have as many people on the same page as possible, right? And again, this one just means the function f of x divided by the function g. And remember, whenever we have fractions, we still cannot divide by 0. So we have to throw out any x that makes the denominator 0, right? So let's see these notions in action, all right? Let's see them in action. Okay. So what the beautiful thing about this group is that because I've kind of, my rhythm is a lot more smooth, we actually have a lot more time. My earlier class, I was running a little late, and then this, that, and the other, and so we didn't have as much time. So let me do the first one, and it's a good idea for everybody to either go ahead and the best is just to screenshot your screen right now, right? So the best thing is just to go ahead and screenshot this, and then so when we break out into breakout rooms, you'll have a copy of this slide, right? So I want to clear. Let's just go like this. I want to clear this. All of this can go. Come on. Let's delete that. That looks good. And okay. So this is a copy of the original. Let me do view. Paper. Like this, right? So I'll do the first one, and again, remember that this is not distributing. We're not distributing there. That's not what we're doing. That just means take the function f, add it to the function g. That's all we're doing, right? So let me do the first one, and then we're gonna break out. We're gonna do some breakout rooms, right? We're gonna break out into groups. So for part A, right? If we have, let me do this. So it says that what f of x is x squared minus 6x plus 8. G of x is x minus 2, right? So then if we're doing part A, thank you. I mean, it's okay. I'm not gonna. I typically don't lock the rooms. I mean, as long as it's not a lot of people being late and it's not an issue getting in here on time, I'll make a big deal about it. Okay, so the first one just means if we have f minus g of 4, right? Again, we're not distributing a 4. What this means, all this means is f of 4 minus g of 4. That's all that it means, all right? So off to the side, we can go ahead and evaluate f of 4 and g of 4, right? We can do f of 4 and get an answer. So if I take my f of x, which is x squared minus 6x plus 8, my x in this case is 4. So I'm going to plug a 4 into those blank parentheses. That's going to be 16 minus 24 plus 8. I think that result is 0. All right. And then the next one, let's go ahead and do g of 4. So g is x minus 2. The x in this case is 4. 4 minus 2 is 2. All right. So then f of 4 minus g of 4 is going to be 0 minus 2, which is negative 2. All right. Okay, style like this. All right. So all we did for the first one, I just evaluated. I did f of 4, I got an answer. I did g of 4, I got an answer. And then the original instructions say basically take that first answer minus the second answer, and then that'll produce your final answer. Right? So that's evaluating operations on functions, right? So then what we're gonna do. Let me see the time first. So again, hopefully everybody has a screenshot of this, and we're gonna take about 10 minutes, right? We're gonna break into 5 different groups. Again, if you're in the first room, so room 1, depending on whatever room you go to, so room 1, you do B. So if you end up in room 1, you do B. If you end up in room 2, you do C, so on and so on. It should follow that format, right? This will be room 3. This will be room 4. And this will be room number 5. Number 5, right? Okay. And we're gonna take like 10 minutes. And then so what you're gonna do, each room is gonna work on each question, and then each room picks a spokesperson. When we come back together, we're gonna need somebody to present their work. However you can do it, you can just walk us through your result, and just walk us through, right? So let's break out into breakout rooms. Let me see if I go here. I want to do some breakout rooms. Do I need to hop back over there? Probably. I want to do 5 rooms automatically. That's good. Is it 25? That's fine. Create breakout rooms. Options. Breakout rooms automatically close after 10 minutes. Let's do, I think 10 minutes will be fine. That's fine too. Okay, so you're gonna receive a notification to join a room, and I'll just periodically be coming around to each room. I'll be coming around to each room to just check on you guys and make sure you're okay. All right. All right, guys. How are you looking?
Well, we just started. Right. We're trying to make sure we have beef because we're on 1.
Right. Yep. Okay. I'm going to move on to the next room, and I'll just kind of circle around a little bit.
Alright.
Y'all have it. Okay, I think you guys are good. Okay, let's go like this. Hey, you guys, how you guys looking? It's awfully quiet in here. Everybody's
Good.
muted. Y'all good?
Nah,
Okay. Y'all
not
have
bad.
are you good? You have your materials and everything. Y'all okay?
Uh,
Yeah.
question.
Go ahead.
So for number 2, since this is room 2, the question is f plus g times x.
It's not multiplication, right? So this is f plus g
No,
of
but that's
x,
the question.
right? So yeah, for part C, what we're doing is basically that notation. It just means f of x. Just add the two functions together. That's all it means. Don't introduce an extra x in there, right? Is that okay? I got a dimple trying to come in. But yeah, is that notation just means f of x plus g of x. So just add the two functions together. That's it. Okay, I'm gonna let y'all kind of work on that. I'm gonna move on to the next room. I think I gotta go back here. Okay, I did this one. I did that one too, so I need to do like this. Okay. Boom, boom, ba da ba da ba da ba da ba da ba.
It's f minus g, and that's the parentheses, and then you got the x in parentheses.
How you guys looking over here?
Good.
You okay? Did y'all have any questions? You okay?
No, sir, not really.
Okay. You're not okay? What's wrong? That's fine.
I know we good.
I know. I asked a double question, right? And one answer was supposed to be yeah, and the other was supposed to be no. So I just intentionally mixed it up. I was just messing with you. Okay, but if y'all are good, I'm gonna move on to the next group. Okay. Let's go like this. That was 3, so let's move to 4. All right, brothers. How y'all looking here? How's everybody doing?
Yeah, I'm lost.
You said you're lost.
Yeah.
It's not. This one is really light. So let's do like this. I'm gonna share, and let's share this. Right. So all we're just doing basic operations on functions, right? So for instance, this is room 4, right? So I think y'all had E. Is that correct?
Yeah.
All this means. Can anybody explain to me what does this mean? What does this notation mean? So let's look at C, right? If we look at C, what does this notation mean? If you ignore functions, just what is yeah, you just add them, right? What does it mean in D? What does that mean?
Mine also multiplying it.
Yeah, so we're just multiplying, right? The only thing is we're don't bring in an extra x, right? Don't bring in an extra x. All this means is basically say the function f times the function g. You just multiply the two functions together. You might have to like FOIL, combine like terms and things of that nature. But all we do is just say f times g and then simplify it down as far as you can. Does that make sense?
All right.
But yeah, do not introduce an extra x. That's a common error that students like to make when they start out. Okay, I'm going to move on to the next room. Let's see. Let's go like this. I think I got to hop this way. And I want room number 5. This one. Did that work? 5. Okay. All right. All right, brothers. How y'all looking here? How's it looking?
Uh,
It's okay. Like, yeah. Did anyone want to ask any questions?
Uh, so I set it up, but I don't know what to do next.
Okay. How did you set it up? What did you do to set it up?
I did x squared minus 6x plus 8 over x minus 2.
That sounds good, right? So then you have a trinomial over a binomial. Can you factor the top part, the numerator? Can you break it? You want to break it up into something times something else, right? If you can factor it
Yeah.
properly, then something should cancel. You should have like a common binomial factor that cancels. Okay.
Okay.
So take
Yeah,
a
okay. I
yeah
don't.
yeah take a few more minutes as a group and kind of be thinking about a spokesperson to present what you guys find. You know, I'm gonna kind of let you guys work for a little bit more and take care. I'll be right back.
Okay.
All right. Almost a disaster. Let's do a screenshot. That'll be better. Okay. Let me see. Okay. So, somebody from room one, do you mind like just presenting like your results and walk us through how you got your result? Can we get a spoke? Oh, and what color can we get the spokesperson? Who's the spokesperson for room one?
Spokesperson.
Who said that?
Gregory.
Mr. Brown. All right. What color you feeling, Mr. Brown?
We can do blue.
I just knew you were going to say brown.
I said blue, but okay.
No. Blue is fine. Okay, so let's see. So what result did you get?
The final result we all got was -1.
-1. Can you walk us through how you got that result?
Yes. Okay. So you're going to substitute that x in the problem itself to 3.
Okay.
So it will be 3 squared minus 6 parentheses 3.
Okay.
And once you solve those individual problems, you should get 9 minus 18 plus 8.
Okay.
Then you're going to get -9 plus 8, and then that answer will be -1.
Okay, the -1 looks good. So then what was next?
So for the g of x, I believe, you should get 3 minus 2, and you should have 1.
And then the final?
The final is the fraction, which is -1 divided by 1 in fraction form. And you should get -1 as the final answer.
So let's see. You did f divided by g of 3. And the answer we got, so this means f of 3 divided by g of 3. F of 3, we got an answer of -1 divided by 1. I can get down with the final answer of -1. That sounds good. Right? That was awesome. Fantastic. Okay. So again, we have a little bit more time, so this is awesome. So it's a completely different experience. And that was Mr. Brown. Awesome. Okay. So can we get a spokesperson from room 2 to, who's our spokesperson for room 2? Do we have a spokesperson for room 2?
I can just go. You could go.
Who's a spokesperson?
So we just agreed that
wait.
It's gonna stay.
Wait, is it Mr. Rance?
Yes.
What color you feeling, Mr. Rance?
Let's go with red.
Red. Okay. So this is part C. This is Mr. Rance. Okay. Sorry about that. Let me clean it up a little bit. Okay. Did y'all say y'all got different results?
No. We just agreed that it's gonna stay as the same formula, like it doesn't change.
Okay.
There's no number.
So what answer did you get?
For f of x, we got x squared minus 6x plus 8, and g of x equals x minus 2.
Okay. I see what you did. Okay. Read it off one more time.
F of x equals x squared minus 6x plus 8.
Okay. And then what was your g of x?
And g of x equals x minus 2.
Okay. Can I get somebody in the audience to fix this for us? Like, so for part C says this. It says this: f plus g. So what change do we need to make? Right, we need to make a change here.
Oh, I now see what we have to do.
Okay. So can you do it on the fly? Give it a go, because I think you can handle it, right? So look, what does this symbol mean? Let's change this color. What does this symbol mean?
What does that mean? Add.
Add, right? So what do you think it means in this context?
You have to add like terms.
Before that, add what?
Oh, f of x plus g of x.
That's all it means. Just add the two functions together, right? And so in application for this one, like you said, we just combine like terms, right? So again, this f plus g of x, all it means is f of x plus g of x, right? So maybe some other groups might have to adjust a little bit, maybe not, right? So now if we add these two functions together, like you said, so let me kind of move it around a little bit. I'm going to move these guys about here just for presentation purposes, right? Like that. So now you said combine like terms, right? So then if we have this, if we take your f of x, which is this, and then we're going to say plus the g of x, which is this. So if we were to combine like terms, how would you adjust it? What would you do on the fly?
it's
Or
gonna be
what are your like
it's gonna
terms? Go ahead. I'm sorry.
it's gonna be x squared.
Okay,
Let's see, minus five
that
x
sounds good.
plus 6.
Plus 6. All right, let's get down with this. All right, so again, for part C, all it just means is add the two functions together, and we essentially just did combine like terms, right? That was pretty good, pretty smooth. Okay, that was a nice save. I like that. But that's how it goes. Can you think on your feet, right? All right, who's our spokesperson for part D, room number 3? Number 3,
I can do it.
Mr. Bell.
Yes.
Mr. Bell, what color?
So basically,
wait. What color?
oh, we can do green.
Green. They say geniuses pick green. You sure you're up for the challenge?
Yes.
Okay, no hesitation. Okay, let me see. So we're doing B, C. We're doing part D. Okay, give me just a second. So this is Mr. Bell. Who sings that song? You can ring my bell, ring my bell. You know that song?
I've heard it before.
Okay,
I don't know who sings it though.
that's okay. Because I don't know who sings it either. I just don't feel so old. Like I know I'm getting older, but it's okay. I'm not. I don't really care. I feel like it's a badge of honor when you get into older years. So, okay, let me just cut this. But what I'm noticing is that I can't do the same references because that's my thing. I can't reference because we all have a different reference point. Like with like just stuff, TikTok and social media and all this other stuff, memes. Like the comedy dynamics have totally changed. So I got to like get some better references. Okay, Mr. Bell, what result did y'all get? What's the time?
So we ended up with x squared minus 7x plus 6.
I heard x squared minus 7x plus 6. Okay. Can you walk me through what did you do?
So we plugged x into f of x equals x squared minus 6x plus 8.
That sounds okay. Let me see. So you're not really plugging in the x, but it's just. I think you're okay though. So you said the first thing you said x squared
minus 6x plus 8.
Minus 6x plus 8, and then what did you do?
And then we subtracted like terms because we use negative x minus 2.
Minus 2. Hang on. Let me see. G of x is x. Okay. So the way I have it written okay? Does everybody agree with what I have written, or can you notice something that I may have forgotten to do? Anybody notice anything? Okay, let me see. So if we're doing f minus g of x, right? So again, let's I'm going to do my commentary, a little bit of commentary here. So again, f minus g, there is a little bit of a caveat here. If we do f minus g of x, again, what does this mean? All this means is just take the function f and subtract the function g, right? But when we subtract that second function, there's something that we kind of got to watch out for. I think the f of x is fine. X squared minus 6x plus 8. Okay, so that's okay. But then the part that you got to watch out for is right here. This, and if we just did let me see, g of x is x minus 2. If I write it like this isn't correct. Can you tell me what I might need to add in order to make it proper? Anybody? So the way I have it written right now is not correct. What kind of change do you think we might need to do based on the colors that you see? What do you think we might be missing? What if so if we want to subtract the function g, we need this symbol. Do you know why? What do we need to do with that negative? I heard it. We need to distribute, right? So whenever we subtract, if we don't put parentheses around that second thing, it's very easy to miss the distributing part. Let me see, did you catch it in your final answer? See, and that's what happened, right? So that plus 6 looks like it's off. I think that's supposed to be a 10, right? But that's what happened. That's why we like do the breakout rooms. And this is actually good. It's good for us to make mistakes as a class. So that way, hopefully, when we're going our own, especially if we're working with like in smaller groups, we'll be like, wait a minute. Remember in class, we did the parentheses. You got to distribute the negative into the second part, right? So then with that change, now let's go back and see, can we take it all the way? So with that adjustment, Mr. Bell, you want to walk me through the rest of it? So then what's the next line?
So x squared
Okay.
minus 7x plus 10.
Okay, so let's do it like this. We still got this. Let's bring this down. Let's go ahead and distribute the negative. So we do get a minus x and a plus 2. And then it sounds like what you said was correct, right? You had x squared. I heard a minus 7x because if we combine like terms, and 8 plus 2 is now 10, right? So the only adjustment was that 6 should have been a 10, but otherwise it was pretty good. And that's an easy thing to miss, especially the first time around. Somebody kind of has to bring it to your attention, say, hey, you got to distribute that negative into the second part, and then we're good to go. That was actually really good. Okay, one philosophy is like there were some experimenters. I'm watching the clock also, by the way. Ooh, we just right on the money. So I think it was I don't know if it was Alexander Graham Bell or not, or maybe Edison. And I'm pretty sure there's some other like experimenters and inventors that I'm just totally not giving credit to. But somebody was referencing these guys, and there was one of them made a quote like I didn't fail. Like that wasn't a failure. That trial was not a failure. I successfully found another way that it won't work. Right? They were trying to make something, and they kept having failure after failure after failure. And he was like, "No, these were not failures. That's not a failure. I just successfully found another way that it won't work." Right? And then so like also the energy is a million no's and one yes is still a yes. Right? And so like within reason, obviously there are some venues where you don't want to hound people like that. But if you're doing like, just like self progress and like trying to just improve yourself, then again, a million no's and one yes is still a yes. And as long as we keep going until we achieve it, if we fail failure after failure after failure, but then we finally get a success, again, a million no's and one yes is still a yes. Anyway, so we don't really fail until we quit. As long as we don't quit, we don't really fail. Those are the energies I wanted to kind of convey. Let me see. I think there's one more. Can we? But that was. Oh no, there's two more. Oh. Okay. Can we get the spokesperson for room number 4? We got a spokesperson there.
I'll go.
Mr. Gunn. Okay. Mr. Gunn, what color are you feeling?
What colors? They didn't took green and blue already, didn't they?
Yeah.
Guess I do red.
Let's do. Give me another color.
Oh wow.
Oh, okay. Did anybody do red? Wait a minute. Yeah, give me another color.
Hey, you got orange left?
We can do orange. Okay. This is Mr. Gunn, right? Mm-hmm. This is D. No, A B C D E. Okay, for E, again, this is Mr. Gunn. I'm watching the clock, guys. I think we had F times G of X. Can you tell me what result did you get?
Well, it's not the same result. After I watched the addition, I changed my answer.
That's okay.
Basically the way how to do it.
Did you get a final result?
Yeah, I got x2
okay.
minus I'm tripping. X squared minus 6x minus 16.
Let me think about this. I feel like we might need to do some more adjusting. Let me see. Yeah, we're definitely gonna have to adjust again. Walk me through what you did, though. Walk me through what you did. How'd you get that? So like.
So basically,
Go ahead.
So same thing as the basically how the addition went.
Mm-hmm.
I basically just plugged it in. So I did positive 8 times negative 2. Then I got negative 16, and then negative 6 times 1 is negative 6x. So
okay. So it's kind of there. Like for instance, what if I did this? So what if I wrote the following? What if I wrote like this times, I don't know, this. If I wrote this, how would you? What technique would you use here? Aluminum what? Foil, right? So basically when we foil, we make sure that each term in the first one gets multiplied with everything here, and then this also gets multiplied with everything here, right? So the same way we foil when we have a binomial times another binomial, we actually need to foil here as well. but it's a little bit different, right? So we got to say x squared minus 6x plus 8. That's f. And then we got to say times the function g, which is x minus 2. Right? So again, this notation means f of x times g of x. We're just basically multiplying the two functions together. And so that means this. Sorry, not that one. That means this one down here. Right here. All right? So then we have to FOIL. So this x squared needs to get multiplied with everything. Negative 6 needs to get multiplied. 8 needs to get multiplied. Then we combine like terms. Okay, I'm going to leave this one as an exercise because we're out of time. I'm going to leave this as an exercise. All right, so work on it. And you have it. We have a typed up version. You can use it. But we need to FOIL. FOIL and then combine like terms. I'm going to say FOIL, then combine like terms. Okay, so a little bit more there. And then I'm just rushing because we're kind of short on time, and I want to honor the time. Can we have a spokesperson for F? Who's our spokesperson for F? Come on, we're trying to get everybody out. Let's be quick. I'm not gonna leave you hanging. It's okay. Uh-oh. Who's trying to go? It's real choppy. Okay.
You hear me?
Mr. Chambers. Okay, go ahead. What color you feeling, Mr. Chambers?
Okay, so the answer I got for it was
wait. What color you feeling?
I'm sorry, you said what?
What color are you feeling?
Oh, yellow.
Okay, let me see. I think I can see this one. Okay, this is F, and then you had this. Okay, did you get a final result?
Yeah. Is it x minus 4?
Okay, and how did you get that?
So I put x squared minus 6x plus 8 over x minus 2, and then I factor the numerator.
Okay, hang on. So this means if we say f divided by g, again, this means f of x divided by g of x, right? Just basically divide the two functions. F of x was x squared minus 6x plus 8. You said divided by x minus 2, right? And then I heard, what was the f word again that you did with the top?
I factored it.
He said he factored the top, right? Okay. And what does it factor into?
X minus 4 and x minus 2.
Minus 4, minus 2. They multiply to give us 8. They add to give us negative 6. This looks good. And then what happens?
So and x minus 2 and x minus 2 denominator, they cancel each other out.
Now that we have all multiplication and division, we can cancel factors, and I can get down with this answer.
Okay.
That looks good. Okay. So that was an experience. That was a journey, right? Again, it's good that we have whatever experience we had together, so that way, when we get on our own, hopefully we can have fewer people like doing things like distributing the x, because that's a common mistake that students like to make, distributing the x, and it takes a little bit of practice. You'll see these are kind of okay. I like this topic, but just give it a go, and we'll pick it back up here next time, right? So we're gonna stop here for today. And on that note, we're gonna end the session here, and from one beautiful mind to another, enjoy the rest of your day. Deuces up, A-Town down. Peace. All right, guys. See you tomorrow.
Thank you.
Yep, my pleasure. All right. We did all this. And then Tuesday at what, 5:15? Yeah. I'm just gonna change this. Whew, it is hot. Why is it hot? 5:15 p.m. That was pretty good though. Okay. So we're gonna stop the stream first. That was good. Zoom, we can just quit. Let's go here and stop the stream.